So our topic for today is radio access network deployment. So how radio access network are deployed in a country or in a specific target area. Okay. So let's have a quick recap on the network nationwide mobile coverage. So the one that gives us the mobile coverage are the radio access network or RANs. So typically you will hear the word cell site. So cell site is part of the RAN. So cell site is one part of the radio access network. Pag samasamahin mo yung cell site, you will build what we so called the radio access network. And the cell site is composed of antennas, as mentioned by Engineer Dika, jumper cables, okay, remote radio unit, CPRI or the common public radio interface, the baseband unit, the power supply, and the transmission, and including the tower structure. So we are building different or numerous RANs in different parts of the country, or not only in the Philippines, but in different countries as well. So we have a seamless mobile coverage. So meaning we need to give a signal to subscribers. Yeah. So thousands of RAN elements create seamless coverage and for mobility. Okay. And the radio access network as well is using the most important resource in a wireless network. So that is the spectrum or the frequency. Okay. So because the radio access network forms the essential bridge between the mobile devices and the core network by utilizing the radio spectrum. Okay. So this is the radio spectrum, which is a finite resource comprising various frequency bands. So napakalimitado ng ating mga spectrum. And if you look at the spectrum band that Engineer Nika showed you before, so it is composed of two parts. It's a non-ionizing radiation and ionizing radiation. So there are two types of radiation. So those non-ionizing, so these are the radiations that do not have any health effects on human body. Now, if you go for ionizing radiation, starting from ultraviolet light, X-ray, gamma rays, or cosmic ray, okay, so those are the harmful radiations that gives us an not good effect on our body. Okay, so good thing is that these radio access networks, including the televisions, mobile phones, Wi-Fi, microwaves, are using non-ionizing radiations. Okay, so later on I will show a supplemental video with the Department of Health. So just to answer some clarifications you have in mind about radiation, because radiation is not necessarily a bad word, because in terms of technical, I believe most of the ECE, especially the ECE students or professionals, know that the radiation is a transfer of energy. This is a means of transferring heat energy from one place to another through space or through a vacuum. Okay, so there are different types like convection, conduction, and the other type is radiation. Okay, radiation is a misconcepted na word na parang meron laging bad connotation. Okay, but this is just a means of transferring heat energy. Okay, so spectrum is a fundamental asset that provides an wireless connectivity, and then it is an invisible electromagnetic wave generated by a radio transmitting device. Now, for ECE students or professionals, what type of electromagnetic wave that is only visible to us? Ano yung electromagnetic wave na nakikita natin? Can you type in? Ano yung electromagnetic wave na ating nakikita? Do we have something na electromagnetic wave na nakikita natin? You can type in sa chat box. Yes, no? That's correct. Visible light. So ang ilaw na nanggagaling sa araw, na nanggagaling sa inyong lamp, sa inyong incandescent bulb, sa kandila, is an electromagnetic wave. Okay, so that is part of an electromagnetic spectrum. So that's why if you are outside or under the sun, so you are exposed to an electromagnetic radiation, right? Okay. So ang ano lang is mas malakas ang power ng sun. Okay. Thank you for those who participated in the chat. Okay. And the spectrum is about frequency measured in hertz. No? So galing to kay Heinrich Rudolf Hertz. And operators acquire a license. So not everybody or not everyone is allowed to use the spectrum. So here in the Philippines, you need to have uh, an approval from NTC, especially if you're using those frequencies assigned in the cellular frequencies. Pero yung sa mga Wi-Fi natin, like the 2.4 and the 5 gigahertz, we don't need to. Pero kasi these are free to use. But if you're using a frequency from 450 to 3.5 gigahertz, definitely you need to have a permit from NTC. Okay. Okay, so operators acquire a license to use certain frequencies for a given period in return for paying annual fees or what we call the spectrum users fee. Okay, and the licenses are normally 10 to 20 years in duration. Okay, so sino-sino gumagamit ng mga frequencies? So the spectrum contains all frequencies in the universe. Okay, not only in the Philippines, not only in the world, but in the universe. So used by different types of services like satellite, mobile, TV, emergency services. So the cellular network is operating between this very high frequency and ultra high frequency. Kasama tayo ng mga television, okay, ng FM, okay, Wi-Fi, 4G, 5G. And now we're extending the frequencies to the super high frequencies. No? Pagdating ng 6G, we will hear the word 6G frequencies yung mga terahertz. No? Okay? So, it goes from very low frequency to extremely high frequency. Even yung ating voice has frequency. Okay? Yeah. So, nandito tayo sa very low frequencies. Okay? So, alam na natin na ang cell sites natin or radio access network ay gumagamit ng frequencies or electromagnetic wave para mag-transmit ng ating information from the cell site going to our loved ones or subscribers and from subscribers going back to the network. Okay? So, why do we need, Why do we need to build a radio access network? Okay? Especially, we want to address these connectivity challenges. Okay, so especially when during the pandemic, we have felt the tremendous need for connectivity, right? So the challenges outlined as follows, So you have limited access in remote areas. So who among you are living in remote areas or know someone that lives in a remote area where there's a lack of access? You cannot contact them, okay? It hinders the residents' ability to connect or even send you a simple text or SMS. So we need to address these challenges. Next is the social connectivity. So it reflects the difficulty in maintaining personal and professional relationship in the digital age. Okay, that's why they say connectivity is now part of is part of necessity sa human life. Especially digital connectivity. And then, of course, emergency services accessibility. So the distant and scattered buildings imply a sparsity of essential services. So in such landscapes like this, what you're seeing on your monitor, the absence of reliable communication can delay emergency response times, potentially putting lives at risk. Just imagine merong emergency sa barangay nyo, How can you contact those barangay tanots to help you or the security guards if there's no connectivity? Okay? And of course, there is what we so-called the technological isolation or the digital divide. So this disconnection not only limits access to information and technology, but also hinders educational and economic opportunities. So dito papasok the calling for the ECEs. If you will see some of the social media publications that we create, especially for terrorists, we're calling out to produce more ECEs. Because it's not only about how much you will make, It's also about what impact you can make sa ating society, especially for our country. Okay. So ECEs are the ones who are also responsible for making this connectivity become seamless to all throughout the country. Of course, not only ECE, but ECE students or ECE professionals play a crucial role in making this happen. Okay. So what do we want to do? No? So we want to have like this, a connectivity. No? So to have the summation of the connectivity that will improve access to healthcare, education, and economic opportunities. Remember, there's statistics that where there is no connectivity, there is poverty. No? Kung saan walang connectivity or walang internet, nandun ang kahirapan. Okay, so that's why if you have connectivity on a certain area, it will manifold yung mga improvements sa healthcare. So people can now connect their doctors online, connect to the doctors online. Especially, there's statistics coming from DOH that 60% of the Filipinos are dying without even consulting a doctor. Kaya hindi nila ma-access yung doktor nila dahil unang-una, isa sa mga reason is that there is no connectivity in the area. So during the pandemic, ang daming naging platforms to connect to our doctors to help us remotely. Just imagine if there's no connectivity, how can you consult your doctor remotely? Okay? Number 2 is education. Have you remembered those teachers na nasa bubong and then finding a signal? Did you remember that? Yung mga teachers na nasa rooftop, just check kung may signal or wala. So that's a problem of connectivity. And as a ECE or a technical professional, so you need to, that's a calling, it's a calling for you. Na, there's a huge problem that we need to solve. Okay, that's why in Terahertz and Asia Open Academy, we are part of building those solutions, helping those decision makers on how to build this kind of network. Together, of course, with our operators and vendors and other players in the ecosystem. Okay. So by extending the reach of modern telecommunications through innovative solutions like building a radio access network, these remote communities can experience a substantial uplift in quality of life and integration with the wider world. Okay, so you can see here, once na na-build na natin yung radio access network or yung cell site, so there's a connectivity. People can make voice call, they can connect to the internet, they'll have a mobile access, even IoT devices. So the DOH has what we call the RX box. So these are portable test devices that can check your blood pressure, monitor your sugar content, or even do ultrasound for pregnant women para makita nila yung kalusugan ng nanay at nung sanggol or ng baby. And then they can transmit it to the PGH for further analysis. Yeah, so that's one of the significance of having a connectivity. And you can also have a fixed wireless access that you can extend inside your house. And the connectivity of the radio access network is we need to connect this radio access network, as mentioned by Engineer Nika. We need to connect this going back to the core. So if there's a backhaul connection like fiber optics or microwave, we can connect it back. Now, if there's a challenge in connecting it to the core network dahil sa terrain or walang fiber optic, now you can have the option to use Starlink or satellite backhaul. So you will transmit the signal going to Starlink, going to ground station, going to the internet, and going back to the core network. Okay, so these are the simple, one of the simple solutions that we can provide, to have a coverage in an isolated area. Okay, so how do we build a radio access network now? So this is the task of the radio access network engineers like me. So we will discuss the processes and the steps in building a radio access network. So you can understand bakit sa area ko wala akong cell site, no? Why in some areas there's a lot of cell sites, no? So there's a lot of considerations. So in this session, you will somewhat understand, or you will have an idea or insight, how do we build a radio access network. It's not as simple as pinpointing a location and then build a tower. Okay, so there's a typical usual process. First, there's a business plan. Okay, so remember that telecommunications is one of the industry that generates a lot of money. So business plan. So there should be a business plan. So you can see that in some areas there are only 2G, there are only 3G, there are 4G and 5G. So why is it like that? So the main reason is the business case. So for example, if you are thinking right now, why in my area wala pa tayong 5G? So there might be a business case that in those areas very few are owning or holding a phone that is 5G capable. Okay? Remember the cost of equipment, the software, the deployment, the maintenance, and operations cost a lot. No? So, malaki yung halaga, no, na ginagastos dyan. So, if there is, kung wala namang gagamit ng site, no one's using the 5G because people are not having a 5G phone, so it's no-brainer na wag tayo mag-deploy muna ng 5G dyan. Okay, so that's one of the factors. Okay, that's one of the factors. Okay, so there should be a business plan. Or there could be a mandatory requirement from the regulatory body. Okay, so the government is pushing or mandated the operators to have a coverage in that area. Okay, so that's number 2. Number 3 is there's a customer complaint. Okay, so operators needs to address a complaint. So sometimes they need to build a site, or sometimes more often is they optimize the area. Okay, optimization of the site. Okay, so there's a lot of reasons. After the business case or the business plan, so there will come the radio network design. So dito na papasok yung mga radio access network engineers. So they're doing the design. So una, they need to identify what is the location, where's the location, what is the requirement, how many people are there, ilan yung population, target population, what is the typical subscription of the population. Mahilig bang mag-SMS yung mga tao? Would they like to have a voice call? Are they using Skype? No, not Skype. Viber or WhatsApp? Okay. Or are they using more often the Facebook? Or they're using Facebook Live? Nagda-live ba sila? Nagda-download ba sila? So those are the different factors that need to consider. No? So we build this design. Okay, so after the radio network design is the site acquisition. So once we identify the area, so there are 4 major people, no, that goes to the site. Merong 4 na taong pupunta sa area. So the team leader is the radio network designer or the R&D. We call them sometimes RF, the radio frequency engineers. So sila yung team leader niyan because they know the coordinates, they know the design because they are the one who made the design. Okay. Number 2 is the transmission engineer. Transmission engineer ensures that there will be a connectivity from the radio access network going to the core network. Okay? So dito papasok yung transmission engineer, no? Okay. Yan. So there should be a connectivity from your radio access network going to the core network. Okay, that is the task of the transmission engineer. The RAN engineer is responsible for the coverage, okay, of the cell site. Okay, and the other one is the civil engineer. Okay, so one of the important team member of that design, the civil. Are there any civil engineers here? So they decide kung anong type of tower is sufficient to support the requirement of the transmission and the RAN engineer. Okay, for example, there's a lot of antenna that will be put on the cell site. So it's not the task of RAN engineer, baka bumagsak yung tower. No? And it's not the task of transmission engineer. So it's the task of the civil engineer. That's why in the early discussion of Engineer Nika, she mentioned the different tower structures. You remember that? So there's a different tower structure. So the one that is deciding on the different tower structure is the civil engineer. Okay. And one of the decision factors is the requirement of the run engineer and the transmission engineer. Okay. And the other one is the other member is one of the important also, no, is the site acquisition engineer. The site acquisition engineer, although sometimes he's not an engineer, he handles all the documentation. Okay, the building permits, the DOH permits, municipal permits, provincial permits. Okay, contracts, lease. Okay, so those paperworks, no, and those permits. So we have 4 members: the run engineer, transmission engineer, civil engineer, and the site acquisition. Okay. So after we finalize that area, so nakausap na yung may-ari ng lupa, okay, so dito na itatayo yung cell site. So we finalize the coordinates, we finalize the tower height, the tower structure. So we go to site engineering. So this is the time where we prepare the bill of quantity or bill of materials, no? Okay. So how many antennas are needed, how many radios are needed, what type of tower is needed, how many microwave antennas are needed, okay, what power supply is needed on that area. So that is part of the site engineering. And in parallel as well is the civil works. So the civil engineers are starting to build the cell site in parallel. Okay, so they maghuhukay na yan, okay, maglalagay na yan ng mga bolts, and then they start to build the tower structure. Okay, so after building the tower structure, the installation team will go there. So they will put the antennas, they install the antennas, the RF antennas, the transmission antennas, the radios, the cables, the baseband units, and the power supply. Okay, so the one that mentioned by Engineer Nika earlier. So that's the installation stage. So after we install everything, equipment, the physical on site, the integration engineers will come. So integration engineers could be an ECE, could be an IT, could be a computer engineering, especially if they want to integrate the site, no, to the core network. So integration is the next step. Okay? So integration is bubuhayin natin yung site. So once na the site is up or on air already, so that's a time that you can see that you can make a call. You can connect to the internet. Okay? You can see the signal bar on your phone. So there's a connectivity already once integration is complete. But it's not yet commercialized until dumating yung mga optimization engineers, which is also part of the run engineers. So ang specialization lang nila is the optimization engineer. So optimization engineers are the ones responsible for initial tuning. So initial tuning meaning they will do a drive test, they will do a testing, they will do voice call, SMS, download, upload, to see if the site is working according to plan. Okay, so they might tilt the antenna, repan the antenna to cover the specific target areas that they need to serve. Okay, so that is we call the initial tuning. So once all parameters are aligned, okay, so and working, so we will announce that the site is ready for commercial launch. So that's the time that the marketing team will sell SIM cards or build some promos and encourage people to use the network. And after that is the performance management and optimization. Once the traffic is there, okay, a lot of traffic is coming in, okay, so you need to have a performance management and optimization. And the cycle goes on and on. And then you will see that there's a new business case that currently right now operators are not the one building the tower, but it's a tower company. So it's the same, but it's the same process. It's a change on business model only, or the operations, how the operators are operating, and new ecosystem players are coming in. Okay, so how does a radio access network provide mobile coverage? So for example, this is the area. So later on, if there's a time, I will show you how we build, no? How we do the design. So if this is the area, so if this is the area, or if this is the target area where we want to cover the subscribers, so usually we have what we call the search ring, no? So the 4 guys that I have mentioned, the RF or the RAN, the transmission, the civil, and the site acquisition will go here physically. So to check out the site, we call it the site survey, the technical site survey. So they will survey the site and then they will decide that, okay, this is the best place where we can put the site. Okay? Itong pinakamagandang location. So the RF will say yes. The transmission will say yes. I can connect from this cell site to another cell site to make it to the core. And the civil engineer will say yes, the land area is sufficient to build a self-support tower. No? So meron tayong 20 meter by 20 meter, it's okay. No? And we will give it to site acquisition engineer to secure all the permits. Yeah. So once we build it, once we fired it up, so you will see na previously walang coverage and now the area will have coverage. So you will see here yung mga different color no schemes. So ang ano lang nito is full bar kapag ka nasa dark blue, okay, mga full bars yan kahit nasa loob ka ng bahay. And you will also have full bar if you are outside your house. So there's a lot of criteria. Okay. Definitely if you are very far, no, just like Celine Dion, near, far, wherever you are, napakahina ng signal na makukuha mo. Okay, so very far ka na. Sa ano ka na, sa malayo ka na. Okay, so that's why we try to build the cell sites near the subscribers. Okay, not so near na nakatapat sa mukha mo yung antenna, of course. Okay, so for those who are worried about dun sa sinasabi ng radiation, I will show you another video on that one. Okay? Okay, so before we go to the different cell sites, no, or different evolution of the cell sites, let's see, no, if delikado ba talaga, no, ang cell site. What do you think? So safe ba ang mga cell sites? Are cell sites safe? Or yung mga radio access network. So I will show you, no, a video from Globe and DOH. Yan, Globe and DOH. Okay? So I hope you can see the screen. I will share also yung yung link dito. Okay? So I will share you also the link. So you can share the link for those people who have worries, no, about may cell sites sa paligid natin. Hindi tayo makapagtayo. And you're suffering for low signal level, no? So ikaw inis na inis ka dahil walang signal and then somebody from your village is opposing, no, yung pag-build ng cell sites. So that is frustrating actually. You cannot make calls, no, hindi maganda yung connectivity, and then suddenly there's a plan of building a cell site and then you have heard na hindi pumapayag yung homeowners association dahil sa maling notion that there is a health risk, no, of building a cell site. So you can share this link to them. So you can also educate them na ano ba yung mga effect talaga ng cell site sa human health. So let's watch this video together.
Actually, yung DOH still maintains its stance doon sa press release na na-issue noong 2001. It states that no study proving cell site can cause cancer. Marami pang mga pag-aaral na ginawa sa abroad. There are several decades of studies. There's still no conclusive evidence that cell sites can cause adverse health effects. Dapat ang pananaw, huwag matakot pag may nakita na cell sites. Kasi ang cell sites ay nag-i-emit ng isang klase na radiation na tinatawag na radio frequency radiation. Ito ay isang klase ng radiation na classified as non-ionizing. Pag ito ay sinabing non-ionizing, itong klase ng radiation ay mababa lang na energy na hindi niya kayang i-break yung molecular bond na makapag-damage sa DNA ng mga cells. Sa totoo lang po, even without cell sites, exposed na tayo sa radio frequency radiation. Kapareho ito ng ini-emit na radiation coming from TV station, AM and FM broadcast stations. So, masasabi ko noon pa, exposed na lahat ang tao sa ganitong klaseng radiation. Marami kasing gumagamit ng cellphones sa buong mundo. Kung maraming cellphone, syempre, kailangan magpatayo na maraming cell sites. Kaya tinatayo yung mga cell sites to improve communication and connectivity. So, dalawang reason lang yan. We install cell sites to increase coverage and to have sufficient capacity. Sa ngayon po nakikita ko, parang hindi na tayo mabubuhay nang walang cellphone or cell sites. Naging parte na ng pamumuhay natin.
Okay. I hope it clarifies, no, yung mga worries nyo, no? So let me just share the link so that you can use it also. If you just happen to discuss with somebody else na iba yung perception about cell sites, no? Okay, I'll post the link in the chat box. Yeah, you can use it. Yeah. So not only the DOH, right? So in the international community, there are, of course, there's a lot of study in the international community about this effect. And one of the organization that handles this is the International Commission on Non-Ionizing Radiation Protection. You will see this logo when you first buy a phone. So tingnan nyo yung papel ng phone nyo. And sometimes there's an ICNIRP logo. Okay, so if there's an ICNIRP logo, so meaning dumaan sa kanila yan. Okay, so meaning ng ICNIRP ay International Commission on Non-Ionizing Radiation Protection. So what does the ICNIRP do? It aims to protect people and the environment against adverse effects of non-ionizing radiation if there's any. So they are also recognized as an official collaborating non-state actor by the World Health Organization or WHO and the International Labor Organization or ILO. So sino bumubuo, no? Who composed, no, this organization? This is composed of experts from different countries and disciplines such as biology, epidemiology, medicine, physics, and chemistry. They work together with and within the ICNIRP to assess the risk of NIR exposure and provide exposure guidance. Okay? Do you see any blogger here? Wala namang blogger dito, right? There's no blogger here. So if you see a blogger here na kasama sa ICNIRP, that's the time that you believe them. Okay? Okay, so if you look further sa ICNIRP, so I will also share with you the link so that you can have further studies or research about this. So you will see that in the ICNIRP, they are looking at the frequencies from 100 kilohertz to 300 gigahertz. Remember, our frequency is within 450 to up to now, no, 3.5 gigahertz. But this one is bigger, from 100 kilohertz to 300 gigahertz. Anong sinasabi nila dyan? It says that after several decades, parehas na sinabi ng DOH, after several decades of RF-EMF research on numerous potential health effects, the only substantiated effect of RF-EMF exposure relevant to human health and safety is heating of exposed tissues. Medyo mainit. Parang telepono, mainit kapag ginagamit lagi. So RF-EMF fields can penetrate into the body. The higher the frequency, the lower the penetration depth and cause vibration of charged or polar molecules inside. This results in friction and thus heat. There's no other effect aside from heat. Okay. So that's the study coming from IC and IRP. Okay? And remember, the frequency is the key asset for mobile operators. So if we will not use the frequency, it will be very difficult for us to have a wireless connectivity. The frequency is something like a road, parang kalsada. The bigger the road, the more capacity that we have. Okay, so para yung kalsada that takes our data from your mobile phone going to your cell site, and your cell site going to your mobile phone, right? So it gives you enough capacity and coverage. Pag sinabi nating capacity and coverage, is something like this. Coverage means you have a signal. Meron kang signal. Sa yung cellphone, if you look at your cell phone, you have a 1 bar, 2 bars, 3 bars, 4 bars, okay, even 5 bars. That is coverage or signal. But when we talk about capacity, is that is the system have enough bandwidth for you to be accommodated? Okay, makakatawag ka ba kahit may signal ka? Makakapag-download ka ba if you have a sufficient signal? Or can you make a video call? No. So is there enough capacity for you? So if you will look at it on a perspective ng kalsada, merong kalsada, pero madadaanan mo ba? Hindi ba traffic? Hindi ba siksikan? No. I hope you can correlate with that kind of analogy. Okay? So marami tayong frequency ginagamit sa ating wireless telecom system. So nabanggit ni Engineer Nika na ang ating modes of operation is meron tayong FDD. So meron kang telepono, you have your user terminal, and then you have the radio access network or the RAN. And then you have the air interface or the frequency, the radio frequency, no? So you have the uplink, so that is the one that is coming from your mobile to the cell phone. So if you would like to upload your phone or send a feed picture to your friends, so you're using the uplink. Now, if you are downloading, watching movie in the Netflix, watching videos sa YouTube, you are using the downlink path. Okay? So kapag ang frequency ng dalawa ay magkaiba, so we are using the frequency division duplex. Okay? I hope that clarifies everything, no? Para do sa mga ECE students. And for TDD, so you have the user terminal and the RAN, so you are using only one frequency. Okay, but separated by time. Now, if you will explain this, no, I don't want ECE students or professionals explaining this to the non-technical person. I can give you the to use this analogy. Okay, so there's a transmission, no? So you are transmitting your data from cell site going to the mobile phone, and your mobile phone going back to your cell site. Consider the frequency as a road, kalsada. So if you have a road na two-way, okay, two-way, so merong pa northbound and then there's a southbound, you are using FDD. But if you are using TDD, parang sa Cavite, that the traffic enforcer tells you to stop, and then papadaanin niya yung ibang mga mga kotse, and then suddenly stop, and then kay ikaw naman, no, turn. So that is TDD. So meaning you are only using one physical road. Okay? Papaano naman sir nakaka-affect ang capacity diyan? Papaano ko i-explain sa mga non-techie person? So if we are about to explain the coverage and capacity of a cellular network or a radio access network, so it's the same thing like the analogy of the road. So you have the coverage. So the coverage is how far your signal can go. Gaano kalayo ang mararating ng signal mo. Okay? And the capacity. How many people or how many services can your system accommodate? Ilan ang pwedeng tumawag ng sabay-sabay? Gaano kabilis ang download throughput ng 100 tao kapag ka nag-download ng sabay-sabay? Are you getting my point? So that is the difference between coverage and capacity. Can I get a thumbs up if you understand the distinction of the two, coverage and capacity, so that we don't interchange the terminologies. Okay? All right. Okay. So if you are using a low frequency, so that means you are using less than 1 gigahertz. So those are the frequencies from 450 up to 1 gigahertz or 1800 megahertz. Okay? So that frequency range, the low frequency, has the characteristic of propagating far, no? Malayo ang nararating ng low frequency. That's why in the AM, we are using low frequencies compared sa FM, no, na naka-high frequencies. Okay? The propagation loss ng isang low frequency is mababa. That's why malayo ang nararating. So that's why in the coverage, it goes farther than the high frequencies. So what is the trade-off? Of course, may trade-off. Hindi naman pogi ka na, matalino ka pa, di ba? Macho ka pa. Hindi naman laging ganun. Okay? So there's a trade-off. So the trade-off is the bandwidth. The bandwidth is not as big as the high frequency. So may makakadaan, okay? May makakadaan, but not so many. But you have a coverage. So that's why it is typical to be deployed in rural areas. Okay, sa mga rural areas. Isang cell site and then it goes very far. Okay, so it is very a cost-effective solution. Build a cell site, use a low frequency, okay, to cover a lot of people. Okay, so that is the low frequency. While the mid frequency and the high frequency looks like this. So the mid frequency is something like South Luzon Expressway, North Luzon Expressway, Cavitex, CCLEX, or TPLEX, no? Yeah. Anything that is expressway. So meaning it's wide enough and then it's long enough for you to take that. Yeah. Okay? So that's the mid frequency. Kasama sa mid frequency is from 1 gigahertz up to 6 gigahertz. So that's why it's very good to deploy in urban areas, okay, suburban areas, villages, right? Because it's an optimal value for having a good coverage and a sufficient capacity. However, the high frequency band that is ranging greater than 6 gigahertz. So those are the frequencies in the likes of millimeter wave, which is ranging from 20 gigahertz up to 90 gigahertz, okay, on the recent specifications. So kung i-compare natin yan in our analogy, it looks like a NAIA International Airport. So it's very wide that even an airplane, no, can land. Ganun siya kalapad. Okay? But not as long as the mid frequency and the low frequency. Are you getting my point? Is this analogy good enough for you to explain the frequency for a non-technical person? So I hope ECEs, computer engineering, IT can explain it. You don't need to have a degree on communication to just explain this to a non-technical person, especially for your decision makers or anyone that you want to look brainy, sabi ni Engineer Nika kanina. Okay? All right. So I hope this clarifies, no, yung ating analogy for spectrum. Okay. So if you apply this in a radio network, radio access network, looks like this, no? So if you have a cell site, a radio access network, so you have this 28,000 megahertz, which is equivalent to 28 gigahertz. So you can have a 5 gigabit per second speed. That's understandable because the bandwidth is wide, right? Bandwidth is wide. So you can deploy it for hotspot capacity and then fixed wireless, for cafe, okay, sa Starbucks, a coffee bean. So meron pang plug-in sa Starbucks. Okay? So you can use it. And if you are using the mid frequency like the 3.5 gigahertz or the 3500 megahertz, so this is good for urban capacity with massive MIMO. So the frequency, the capacity could reach up to 2 gigabit per second. Okay. And of course, if you are using or covering a wide area and deep indoor coverage such as the rural area, so yung mga probinsya natin, you can use a low frequency like the 700 megahertz or the 900 megahertz or the 850 megahertz or even the 450 megahertz. Okay. So it's a 0.2 gigabit per second. So this is just another, of course, for you to understand. how you can efficiently use the spectrum. It's not just like meron kang frequency, just use it. No, you need a strategy on deploying these kind of frequencies. So let me show you some example of one 5G testing that we have done. This is in a smart network. So they have successfully achieved 1,000 Mbps. So that is 1 gigabit per second using a 5G frequency in the 3.5 gigahertz, 60 megahertz bandwidth. Okay, so this is the one. Okay, so the one that is doing this is the RAN engineer. So the RAN engineer could be a drive test engineer, an optimization, a design engineer. Okay, so on the subscriber side, this is the one that we see, the speed test on the application layer. So remember the different layers that the engineer Nika taught you. So there's an application layer, okay? So yung mnemonics natin sa may ano, ang pulis sa tulay na dapa. Yan. Pag sa US mo din sinabi yon, you will say ang pulis sa tulay na dapa. Yan, medyo konti na lang. Fair to say. Ang pulis sa tulay na dapa. Pag nasa Pilipinas ka, we call it ang pulis sa tulay na dapa. But if you're in other countries, you can say ang pulis sa tulay na dapa. Yeah. Okay. All right. So this is what you see if you are using a different tool. We call it a drive test tool. Particularly, it's a Pioneer, a drive test tool, where you can see the different layers, layer 2, layer 3, and the layer 1. Okay, so these are the layer 1 parameters and different layers. You can see what is a signal level, what is the speed, okay, what are the different parameters set in the network. So later on, sa Asia Open Academy, we will be discussing different parameters of this one and how you will configure a radio access network. Okay. So in the meantime, it's just a high level illustration only. And if we talk about frequency, right? So we're talking about coverage. So this is a comparison of a 900 megahertz compared to an 1800 megahertz coverage. You will see, ang laki ng difference, right? In the coverage. So just imagine we're just using the same power type. Of course, different antenna. So there's an effect of the antenna gain and antenna parameters. But what we're saying is the path loss difference. Okay. So the best way to realize that is to compare the coverage of an 1800 megahertz and the 900 megahertz. So what for those who are not so familiar with the coverage simulation, tingnan nyo lang yung kulay blue. No, ayun yung magandang coverage. Ibig sabihin, meron kang 5 bars dyan. Okay? So in this case, let me just activate yung ating chat box. Which frequency gives you the longer coverage? No, mas malayo yung nararating. Which one? Is it the 900 or the 1800? All right, no? Very good, no? 900 megahertz. Now, the question is ganito. If I will deploy in provinces, like yung mga bahay ay layo-layo, scattered villages. So probably one house has probably 100 meters from another house, and then 200 meters from the other house, and then 300 meters from the other house. If I will build a cell site there, what frequency am I going to use? Is it 900 megahertz or the 1800 megahertz to provide initial coverage? Okay, so 900 megahertz. Why? Why is it like that? Why 900 megahertz? If somebody asks you in the interview, why are you using or suggesting to use a 900 megahertz? It's far distance, wider range, wider coverage, low frequency gives wider coverage. Okay, what else? What else? So remember that during the interview, you also need to say what the interviewer wants you to hear. What else? It's aside from giving you wide coverage, it gives you less cost. Why? Because you're only building one cell site to cover this entire area. Where in fact, if you will build using an 1800 megahertz, probably you need 2 or 3 cell sites. So if a one cell site, probably if one cell site costs you $8 million, so that is around 16 million cost savings if you just build a 900 megahertz. Okay. Okay. So I hope you understand the logic, no, why we are doing that. So that's the fundamental logic. Of course, when you go to the industry and you encounter a very mature network, so probably the strategy could change. Okay, but the fundamental strategy is just like that. Okay. All right. So I hope that gives you enough insight, no, for deploying a radio access network. Okay. All right. So let's move on sa discussion natin. Okay. So earlier, Engineer Nika mentioned that the radio access network has evolved, no, from 1G, okay, 2G, 3G, 4G, and now we are in the era of 5G. Okay, or 5G NR. Okay, so alam na natin yung pagkakaiba-iba niyan. Okay, and she also mentioned the different names. Okay, if you remember the names, just a review, just GRAN, okay, GSM Edge RAN, the UTRAN, the UMTS, Terrestrial Radio Access Network, the EUTRAN, and the NG-RAN. Okay, so these are the different names. Okay, so what we want to achieve today as well is to understand the architecture of the region of the wireless telecom network, right? Because during the interviews, this is one of the differentiator among the candidates. Okay, so that's why in Terahertz I always teach this network architecture, and I enforce them to, or push them to, at least memorize this one slide. Kalimutan nyo na lahat ng slides natin. But this slide, please remember this, and please always practice on drawing this. This is not a complicated evolution, okay? So this is a network architect evolution. This is one way of telling the story of the evolution of the network. If there's a chance that it will be asked you during the interview, this is the best way to explain and tell the story, how the network architecture evolves. Okay, are you ready? Okay, so we start on the 2G because 1G is not so popular though. Here in the Philippines, it's the 2G and in other countries. Okay, so this is remember the three main components of the architecture mentioned by Engineer Nika. So you have the access network, you have the core network, right? You have the core network, you have the radio access network, and you have the user terminals, right? So I believe you still remember this, no? So you have these user terminals, the radio access network, and the core network. So this is the entire end-to-end system, no, architecture. But we will go a little deeper, no, sa discussion ng architecture. So you have the core network on top, okay? You have the radio access network, and then you have the user terminals, okay? So core network, during the 2G, we have the mobile switching center. So that's the one that's handling the switching of calls. If you want to call somebody from Manila and then you're in Cebu, so that's the one responsible for switching your call, okay? And then during that time, it is connected to a public switch telephone network, okay? So PSTN. So you can call somebody sa landline. Okay, so that is the composition of the core network during that time. Although, of course, in the deeper level of architecture, there's a lot of components, but I don't want to bombard you with a lot of information today, right? So we want to simplify things further. Now, if you want to go deeper and you want to learn more about that one, I can give you the entire network architecture of the site. But in the meantime, let's just focus on this simple or simplified architecture. And then you have the radio access network. Okay, so the radio access network is composed of base station controller. We have the BSC. So this is the one that controls the BTS. Okay, dati pa meron ng BTS. Ngayon lang sila sumigat lang ulit. Pero dati nang may BTS. So the base transceiver station. Okay. And that is the composition of the radio access network. And we call the phone or the user terminal as the MS or the mobile station. Okay, mobile station. So if somebody is asking you to use the phone, so it's better to say the word, can I borrow your mobile station? Just the sound brainy. Sabi nga ni Engineer Nikan. I have a new word ngayon. Okay. Can I have your mobile station number? Okay. All right. Now it evolves to packet data. So the GSM has evolved from voice and SMS to a data network. So meron tayong enhancement or add-on. So that is the GPRS, if you remember the word. So this is the one that when you see on your phone na meron sa signal, meron nakalagay na letter G. So that means GPRS. And GPRS means General Packet Radio Service. Okay, GPRS. So ang bilis niyan, nasa 50 kbps. But most of the point of sales, yung mga pag bumibili kayo sa mga malls or sa restaurants, the one that swipe your card, so those are the point of sales. Those are using the GPRS. But modern POS are using LTE now. Okay? And then in enhanced pa yan, we're using Edge. So this is the one that when you look at your phone, you will see E. So E means enhanced data rates for GSM evolution. So Edge meaning that is the last part of evolution ng GSM. That's why it's called also the Edge. Okay, galing ng marketing brand yan, Edge. Okay? And then, sa core part, merong improvement na nangyari. So, they built what we call SGSN, the serving GPRS support node. So, that is the one connected to the BSC. Okay, actually, may connection din yan sa MSC. And then GGSN, the gateway GPRS support node, pabalabas ng network. So this is the internet or the data or IP network. Okay, so ito yung kabuuan ng network architecture for 3G. Okay, so simplified. Take note, it's a simplified. But if you want to go deeper, there's a more complex network architecture. But if you want to just tell the story in an interview, just draw this simple architecture. Okay? Now, what happens is that 3G came. Anong nangyari sa 3G? So, when 3G came, nagdagdag lang tayo ng additional radio access network. So, we call the controller as the radio network controller. Okay? Radio network controller. So, UMTS means Universal Mobile Telecommunication Service. That's a 3G system. The controller is now called the radio network controller, and then yung mga cell sites natin or the radio access network, okay, is now composed of the RNC and the node B. Okay, so when you see a cell site, merong equipment yung cell site, we call it the node B kapag 3G. But this time, yung ating telepono is not anymore mobile station. If you want to use it in your daily life, can I borrow your user equipment, please? just to sound brainy. Okay, so user equipment. So ito nangyari. Now, dumating si LTE. Yeah, so LTE came, we introduced new core. So in the new core, we have what is called the EPC. Okay, the EPC, the evolved packet core. EPC. Okay. And inside the EPC, actually marami yan, marami yan nodes na yan. But we will just mention the two, the control plane and the user plane. Okay, for the user plane, the control plane, the one that is controlling all the mechanisms of going to the core network, we call it the mobility management entity or the MME. Okay, so this is the start where we have separated the user plane and the data plane. Okay, just imagine the data plane. This is the place yung truck mo na mayroong karga-karga. So, you're using the frequency, diba? Yung kalsada. So, para dumaan ka sa data plane, dala-dala mo yung payload mo. But hindi ka makakadaan unless payagan ka ng guard makadaan doon sa barrier. So, the guard is the control plane. Okay? Para, meron ka bang papeles? Okay, saan ka pupunta? Where are you going? Do you have approval to go here? So, that is the function of the control plane. So the user plane is just the payload. Okay, yung truck na may dalang graba or something. Okay? So the payload goes to the SGW, okay, the serving gateway. Yan. And the serving gateway is connected to the PDN or the packet data gateway. Okay, so that is going out of your network. Okay. Now the cell site's equipment is now called eNode B or the evolve node B. So kapag naglalakad ka sa kalsada, you're with your classmate, okay? So your classmate said, "Oh, there's a node B in the area." Ah, sound brainy, okay? And then suddenly nakita mo meron kang LTE signal. No, classmate, that's not a node B. No, I have an LTE signal. Probably that is eNode B, perhaps. Okay, so meron kang eNode B, evolve node B. So you just start using the word so that it can go to your system. And the telepono is, we call it the user equipment. Yeah. All right. So that's the evolution. So now we have a new core and then we have a new radio access network. What is unique here is that the control function of the BSC and the RNC is not anymore separated. It's now embedded in the eNode B. Yeah. Okay. So wala na tayong controller. Nasa eNode B na. Okay. Now, dumating si 5G. No? So 5G craze is happening. So kinakailangan din mag-deploy ng 5G para hindi tayo mahuli sa uso, right? Although eNode B or the LTE is good enough for us. So yeah, let's deploy 5G. That's a cool thing. All right. So if you want to deploy 5G, do we need to build a core network? Yes. We call it the 5G standalone. But if you want to deploy 5G fast and efficient, we can just use what we so-called the non-standalone or the NSA. So the NSA uses the core network of 4G. Okay, remember that. The NSA, the non-standalone. It uses the core network of 4G. And then there's an X2 connection between the eNode B and the GNode B. The GNode B is the next generation node B. And if you have a 5G capable phone like iPhone 12, 13, 14, and 15 Pro Max fully paid with 1 terabyte of memory, if you see a 5G signal on your phone, that means your phone is connected to the eNode B and GNode B at the same time. Okay, we call it dual connectivity. Okay, or the EUTRAN NR dual connectivity, ENDC. Okay, now do you see a 5G signal on your phone right now? Can I get a thumbs up if you see a 5G signal on your phone right now? Do you see anything? Meron ba tayo nakikita? Or LTE lang? No, no, you will see the richest, one of the richest Filipino people in the Philippines. Naka 5G phone sila. Okay. All right, so that's the story of the network architecture evolution in one slide. Ladies and gentlemen, if you just remember all the terms, acronyms, I know there's a lot of acronyms, but it will give you a lot of advantage if you can just simply draw this and explain this easily to one of your colleagues or to your interviewer perhaps. Okay, so kaya ba tong isulat? O kaya ba tong i-drawing? Can I get a message? Lagay tayo ng dito, panata. Can you draw this? And you type in, yes, kaya. Or yes, I can. Yes, I can. At least mag-embed sa ano natin. Kaya daw i-screenshot, no? No, don't just screenshot, no? Just draw. Draw it. Okay, so if your interviewer said, can you draw the evolution of the network architecture of a wireless telecom system? Yes, just give me a blank paper and a pencil or pen. I'll draw it. Okay, all right. Okay, okay. I hope it's enough for you, no, to get motivated on drawing this one. Of course, now evolution niya. That's the evolution of the architecture. Now, although sa core network, maraming evolution na nangyari. No? So there's cloudification, virtualization that was mentioned during the cloud computing and the edge computing, right? Do you remember that? Of course, sa radio access network, there's a lot of evolution happened. Okay, so from the big cabinet like this in the era of 2G, and then naging flexi, ganyan, ano? And then the antenna systems, okay? So dati we have the antenna, and then you have a very long feeder cable going down. So this is care of Catherine, no? And then suddenly, naging massive MIMO tayo. Okay? So multiple input, multiple output. Massive. Okay? So pagdating ng 5G, by next CPD series, we will talk about 5G, don't worry. And then if you are reading more about 6G, you will hear the word G-MIMO, the gigantic MIMO. The gigantic MIMO. It's not only massive, it's gigantic. Ang laki. Sobrang laking MIMO. So you will see that one, but it's not yet one of the standardized. So it's one of those proposed solutions, no, for 6G. Okay, so this is the base station evolution. And of course, as mentioned by Jerica, meron tayong evolution ng mobile phone. Okay, from Motorola, na mga sikat dati, Nokia, Ericsson, and then the Sony Xperia. Okay, so that's the evolution. Okay. Now, let's see, no, isa-isahin natin, no? Although we still have time. Tingnan natin, ano, si GSM. Ano si GSM, no? The second generation. Where the second generation means the global system for mobile communications. Actually, this is a group system mobile, no, in the European country. Okay, so GSM is a standard developed by ETSI. It's a European Telecommunications Standards Institute to describe the protocols for second generation digital cellular networks used by mobile devices such as mobile phones and tablets. First deployed in Finland in December of 1991. Okay, replacement for the first generation or the analog cellular networks. It's a digital circuit switch network optimized for full duplex voice telephony. And of course, nabanggit natin ito kanina, we have the General Packet Radio Service or the GPRS, the enhanced data rates for GSM evolution. This is the logo of GSM. So this is where we have planned, no, different frequencies na dapat hindi siya magkakatabi. And then when you look at this as well, dito na uso yung piatos. Piatos. But this is actually a honeycomb. So this is the most efficient figure or geometry that the nature can provide. Ibig sabihin, ito yung laging ginagamit ng nature. Kaya dito rin natin bakit piatos or bakit hexagon? Because this is the most efficient, no, geometrical figure na ginagamit ng nature. You can see it's a beehive dun sa mga bato, dun sa isang isla sa ibang bansa. Nakita niyo kapag they form it naturally, they form an hexagon site. Hexagon site. Okay? So this is the GSM. Yeah. So balikan natin yung GSM. So you have a mobile network operator, you have a SIM and GSM phone. Dati napakahirap intindihin ito, but of course a lot of people has their own phone already. So they are very familiar ano yung SIM card at ano yung phone. Okay? And then yung mga functionalities ng GSM, you will see that this is now being applied sa Viber, sa Messenger, sa WhatsApp, where you can do a voice call, even outgoing or incoming emergency calls, data transmissions, and supplementary services. Call forwarding, okay? Call barring if you want to block somebody. Okay? Dati uso na yan, but we call it the barring. Okay? Or advanced charge service, okay? Call hold, okay? Hold lang, teka lang. Okay? Call waiting, tumutunog-tunog kapag ayaw sagutin yung tawag mo. Okay? Multi-party services. Closed user group, yan, meron na tayong Facebook group, meron tayong Messenger group, may Viber group tayo. That's the ancestor, no? The closed user group. Dual tone multi-frequency, meron pa rin tayo nakikita niyan ngayon lang yung keypad is digital. It's not anymore physical keypads. Cell broadcast, nakakakuha tayo niyan during the typhoon. Kadalasan, biglang sumisigaw yung telepono natin dahil sa SMS ni NDRMC. Okay? I'm not sure kung meron pang fax or fax mail or voicemail. Yeah. So those are the different services. If you look deeper sa architecture ng GSM, so ito yung kanina simplified, isang core network lang, but these are the different components, no, ng architecture. But we will not go deeper here. But I will just like to show you ano yung iba pang components ng isang GSM network architecture. Okay? Ayan. Now we go to 3G, okay, because I'm running out of time. For 3G, ito naman yung ating 3G. 3G is a third generation phone, okay? So direct sequence spread spectrum, the CDMA, the code division multiple access system. It uses a 3.84 million chips per second over a 5 megahertz radio channel, and allows information streams to be transmitted simultaneously. Essentially, it uses a code division multiple access. So what is that? No? Ano ba yung code division multiple access? Just imagine you're inside the bar. O wag na bar, fiesta na lang. Baka masyadong sabi, masyadong ano si sir. Bar daw. Sa fiesta tayo, no? So we're in a fiesta, and then a lot of people are talking to each other. So there's a lot of interference, right? If you use GSM and then use the same channel, same frequency, you will not hear each other. Okay? So what we want to do is for the UE and the node B to understand each other and have a communication, a direct communication with each other, we will use a specified code, a unique code, meaning I will talk in Tagalog and you will talk in Tagalog as well. If somebody is talking English and somebody is talking Bisaya, we can still understand each other, right? That happens when you are in abroad and then suddenly you hear somebody say in the supermarket, "Hey, pare, punta tayo dito." You will identify that that is a Filipino, right? Because they use the code that you are using. So that is the code division multiple access. That even though there's a lot of interference in the system, the node B and the E node B can still decipher or understand each other because of that unique code. Okay, so that's WCDMA. Now, if you look at the architecture, so this is the architecture of WCDMA, release 99. Okay, yeah, okay. Now for LTE, okay, LTE. So LTE is a long-term evolution. Okay, so it starts from 3GPP release 8. So maraming evolution nangyari dyan. And LTE can use different bandwidths from 1.4 megahertz up to 20 megahertz. Now, if there's a lot of requirement or capacity requirement, if the 20 megahertz is not enough, so you can do a very special technique or a simple technique like carrier aggregation. Okay, we'll discuss this later on sa mga previous sessions natin. Okay? And if you look at the LTE heterogeneous network, so there's a lot of LTE node Bs or E node Bs. Meron tayong wide, macro, repeater, or a femto. Okay, so there's a lot, no? And this is the core network. So makita nyo, wala na tayong controller dito. And you have a UE. So that is the architecture of an LTE. Now, 5G came in. Okay, so meron tayong 5G. 5G is the 5th generation of mobile communications. Okay. So, mayroon tayong tatlong use cases ng 5G. So, that is the eMBB, the URLLC, and the MMTC, or the Massive Machine Type Communications. Yeah. So, what is 5G? Yeah. So, pag-usapan natin ito sa next series, no? So, whenever somebody asks you, like an interviewer asks you, do you know anything about 5G? 5G, I believe in my previous webinar with a young guy, he said that this is a 5th generation. Probably you will forget my name. So you just said, it's a young guy. Told me that 5G is the 5th generation of mobile communications. We call it NR. Something like a 2G. 2G is GSM, 3G is UMTS, 4G is LTE or long-term evolution, but 5G is NR or new radio. Yeah. And then it is connected to a 5G core network. And I remember what he said. There's 3 use cases. It's enhanced mobile broadband or the eMBB, meaning it can go up to 20 gigabit per second, a massive machine type communications or MMTC. As far as I remember, he mentioned 1 million devices per square kilometer. Yeah. And then ultra reliable and low latency communications or the URLLC. He said it's almost around 1 millisecond of latency. Yeah, so those are the 3. So if you just remember this one slide now, you don't need to remember my name. Okay. So what is 5G? So these are the performance targets of 5G. Okay, you can see it that up to 20 gigabit per second. The reliability, the ultra reliable low latency is 1 millisecond and up to 1 million devices. Just imagine if we plot the 6G target, it's up to 1 terabit per second, no, up to more than 1 million devices and more than 1 millisecond. Okay. So 5G will provide 20 times the LTE capacity, 10 times the user experience, and the millisecond level interface. Okay. Yeah. So these are the different 5Gs, no? Different network, no? Okay. So yeah, no, so I'll give more time for question and answer, and we have a post test pa mamaya, no? But yeah, so the deployment of 2G, 3G, 4G, or 5G goes to this process. And when we talk about deploying, it's not deploying a new tower. Sometimes, most of the time, operators, not only here in the Philippines or in other countries as well, they utilize the same tower. They just upgrade. No, they just upgrade the existing cell site. What they do? Well, they just activate. No? Activate 2G, activate 3G, especially if you're just using the same frequency for each technology. For example, if you have this kind of equipment deployed in your network, okay? So previously, when you are building the technology, you have a different system for each technology. You have the 900, 1800, and 2100. Now you can just upgrade, no, using the same baseband unit, upgrade to additional boards, and then activate in the existing RRU. The antenna is still the same, okay, if that is operating on the same frequency band. Okay, so there's a lot of upgrades. So there are upgrades like this that they use a multi-band antenna or a dual band antenna, meaning the 1800 and 2100 are combined in one single antenna, and the radios are connected to this one. So these are the different solutions only. And if operators are upgrading enough, so they are changing their antenna system, only one antenna. So you will see only 3 antennas, sector 1, sector 2, sector 3. And all those antennas cater all the technologies in the cell site or in the base station, 2G, 3G, 4G. Okay. For 5G, if they're using different frequencies, they will use another antenna. We call it the massive MIMO. In some cases, you will see like this, a combiner solution, if they just want to save on cost. Okay. So you can just look at it. So we can have a few discussion here. Probably sa terahertz natin pag-usapan. Okay.